Hey everyone, welcome back to the channel. Today we're doing a deep dive on RAG, Retrieval-Augmented Generation, and how it changes the game for building practical LLM applications. Whether you're an engineer, developer, or product lead, by the end of this video you'll know what RAG is, how it works under the hood, where it shines, and how to implement it the right way. Quick hook. Imagine an assistant that can instantly pull up facts from your company docs, cite them, and generate accurate answers. That's RAG. Plain LLMs hallucinate. RAG grounds outputs in real data. In the next 5 minutes, I'll walk you through the architecture, the building blocks, a simple demo flow, and best practices so you can start prototyping today. So what is RAG? At its core, Retrieval-Augmented Generation combines a retrieval system with a generative model. Instead of asking the LLM to invent everything from its internal weights, we first retrieve relevant documents or passages from an external knowledge store. Then condition the LLM on that retrieved context to produce an answer. That simple idea reduces hallucinations and allows scaling to domain-specific knowledge without retraining huge models. Why does this matter? First, it enables up-to-date answers because the retrieved data can be updated independently of the model. Second, it helps with safety and factuality, since the model can cite evidence. Third, it's cost-effective. You can pair smaller LLMs with a smart retriever instead of fine-tuning huge models for every domain. Finally, it unlocks verticalization. Legal, medical, enterprise knowledge bases, all accessible through the same pattern. Let's break the system into core components. You have 1, the retriever. It finds relevant documents or passages. 2, the document store, often a vector database that holds embeddings and metadata. 3, the embedder, maps text to vectors. 4, the generator or reader, the LLM that conditions on retrieved context and produces the final answer. Optionally, you include chunking, re-ranking, and a caching layer. Retrievers come in flavors. The simplest is sparse retrieval like BM25, keyword-based and fast. The modern approach is dense retrieval, using embeddings and vector similarity, like cosine similarity or ANN indexes. There are also hybrid approaches, combining both. Dense retrievers are great for semantic search. They find conceptually relevant passages even if the wording differs. Embeddings are numeric representations of text. You'll embed both documents and queries into the same space. Then you use a vector DB, like Pinecone, Milvus, Weaviate, or an open-source option to do nearest neighbor search. Important choices: embedding model, accuracy versus cost, index type, HNSW, IVF, and metadata you store for filtering and provenance. On the generation side, the LLM receives a prompt constructed from the user query plus retrieved passages. You can use different strategies: concat top K passages, use a re-ranker to pick the best chunk, or generate answers iteratively using chain of thought or decomposed prompts. The more structured and relevant the context, the less likely the LLM will hallucinate. Let's walk through an example. User asks, "What's our refund policy for digital subscriptions purchased within 30 days?" Step 1. Embed the query. Step 2. Search the vector DB and retrieve top 5 passages from your policy docs. Step 3. Re-rank and filter by date or product tag. Step 4. Feed the top passages into the LLM with a prompt that asks for a concise answer plus citations. Step 5. Return the answer and cite sources. This reduces risk and gives an auditable trail. High-level implementation steps. 1. Ingest documents and chunk them. 2. Generate embeddings for each chunk using a pre-trained embedder. 3. Index embeddings into your vector DB with metadata. 4. On query. Embed query, retrieve top K, optionally re-rank with cross-encoder, assemble prompt, call LLM, and return result. I'll include pseudocode in the pinned description for a starter repo. How do you measure a RAG system? Use metrics like retrieval recall at K for finding relevant passages, relevance precision, and downstream answer accuracy or F1 against a labeled QA set. Also measure hallucination rate and citation coverage, how often the model cites a retrieved source that supports the claim. User satisfaction and latency are practical metrics to monitor too. A few hard-earned best practices. Chunk documents sensibly, not too big, not too small. Include metadata for filtering. Always log provenance. Use re-ranking for high-stakes answers. Tune the prompt to ask for evidence and citations. Cache frequent queries. Test with adversarial queries. Pitfalls. Relying only on top 1 retrieval. Ignoring stale data. Leaking sensitive PII into embeddings. And overtrusting short context windows. Remember privacy and security. Embeddings can leak sensitive info, so consider encryption at rest, access controls on vector DBs, and differential privacy or token redaction pre-embedding. For compliance-sensitive domains, incorporate human review workflows and maintain an immutable audit trail of retrievals used for answers. Where is RAG used today? Customer support bots that cite product docs, enterprise search across internal wikis, legal research tools that reference case law, medical assistants pulling latest guidelines, and personalized tutoring systems that reference curated course material. In production, teams often combine RAG with business rules and escalation flows. To wrap up, RAG is a practical pattern that grounds language models in real knowledge sources. Start small, pick a single doc set, build embeddings, try top K retrieval with a smaller LLM, and iterate. Check the description for a starter repo and code snippets. If you want, I'll follow up with a hands-on coding walkthrough building a RAG prototype. Drop a comment and like if you're in. Thanks for watching. Links to the starter repo, pseudocode, a checklist, and suggested reading are pinned in the description. If this video helped, hit subscribe, share with your team, and tell me what RAG topic you want next. Hybrid retrievers, vector DB benchmarks, or prompt templates for citations. See you in the next one.